Mucociliary clearance is that first line of defense that the lung has to protect itself against bacteria or any other potentially harmful particle that we inhale every minute of every day. People with cystic fibrosis have a real problem with mucociliary clearance. And this is because that CF protein that is malfunctioning in people with cystic fibrosis is responsible for regulating the amount of salt and water that gets secreted into that airway surface. Now that's important because you need an adequate amount of salt and water to make that mucus that's secreted movable. So ultimately what happens when mucus gets stuck down in the lung, we develop chronic infections, and this leads to really destruction of the airways in cystic fibrosis. So there are several important clinical trials that are upcoming to address this problem of mucociliary clearance in cystic fibrosis. These range from those that are focused first at the CFTR protein itself. So we know that there are a number of trials underway to restore CFTR function, and we know from prior work that once you restore CFTR function, you do indeed improve mucociliary clearance. So this is an important set of studies that are being done. Second set of studies are studies that target a different channel, and this is called the epithelial sodium channel. This channel is again a protein at the surface of the cell that does sort of the opposite of CFTR. It's responsible for reabsorbing fluid out of the airway. We think that if we can slow down that reabsorption, we can do sort of the same thing. We can prevent the dehydration of mucus in the airway. And so there are several trials underway or upcoming that will be using molecules that block those sodium channels, and again, are aimed at improving mucociliary clearance in patients with cystic fibrosis. And finally, there's another way to address this problem, and that is focusing at the mucus itself rather than the salt and water movement. So there are multiple agents currently being developed, some in trials already, that are designed to just attack that mucus, chop it up into smaller pieces, or change its physical properties to again make it less viscous, less sticky, and more movable. We've talked about rehydration approaches, blocking sodium channels, improving CFTR function, using drugs that break up mucus. But there are some other approaches that utilize delivery of a naturally occurring substance to our lung called nitric oxide. It's involved in lots of different processes, including regulating how fast cilia move, the properties of mucus, and has the additional approach that when used at sort of treatment levels, kills bacteria. So this is an approach that may not only improve mucociliary clearance, but may also directly kill bacteria as well. The thing I'm most excited about right now in cystic fibrosis research is the development of new therapies. And we've done a lot of great things up until this point where we're helping everybody to some degree, and certain patients tremendously. I think we're at that tipping point where we're really just leaving the runway, taking off into space, where we're going to be able to help a majority of patients in a really dramatic fashion with new therapies.